Hey guys, this is going to be a video on exponent rules, which for those of you who are following along with your standards is standard EE1. So if you'll stay tuned, we've got lots of practice. You can pause the video as needed if you'd like to try the problems before I go over the answers, and then start it again when you're ready. All right, here we go. Alrighty, the first rule we're going to be looking at is product of powers. So let's take a look at what that means very quickly. Product tells me that I am multiplying two numbers together or more, and powers refers to any number that has a base and an exponent to it. So this is going to refer to how I deal with multiplying numbers that have a base and an exponent. Now the first thing we got to notice is that all of our bases are the same. All the rules we're going to look at in this video only apply when bases are the same. So when I'm multiplying these out, I'm going to write it in expanded form, but the whole point of doing these rules is that you don't have to do this once you learn them. So x cubed, this is a shorthand for saying use x as a factor 3 times. And somewhere along the way, some very bright person realized, hey, instead of me writing out 3 x's every time, let me just write x cubed. And we just have learned that that's what this means, is that this is my base, that's my factor I'm going to use over and over, and this number is going to tell me how many times to write it over and over. Okay? Now I have x to the 4th, which is another 4 x's. And then I have x, and this doesn't have an exponent, so I'm going to throw a 1 on there because that's x used as a factor 1 time. It's not x to the 0, it's x to the 1st. So this is going to be times 1 more x. So there's my group of 3, there's my 4, and there's my 1 by itself. And this is what we call expanded form. Okay, now you don't have to write this out. That's the whole point of doing the exponent rules. What I can do is just take into account what exponents mean. My base is the same because x is still my factor that's being used over and over, and then I just need to look at how many times it's been used. There's 1, 2, 3, 4, 5, 6, 7, 8 factors of x. Okay, now I could have gotten that in a much quicker way. Do you know what it is? I could have just added the exponents. If you think about what's going on here, if I'm multiplying these 3 numbers together, and each one involves a certain number of factors of x. That means everything is getting multiplied. All I really had to do was look at the exponents. There's 3 factors of x, there's another 4, and there's 1. 3 plus 4 is 7, plus 1 is 8. And so that's my shortcut. Anytime I'm dealing with a product of powers, I can simply keep the same base and add the exponent. Okay? One last thing here, we're not adding these numbers. We are adding the exponents because the exponents are showing us how many factors we use, but the numbers themselves are not getting added. The other thing is let's say that this had been 2 to the 3rd times 2 to the 4th times 2. I don't know what happened there. Let's try that one more time. 2 to the 4th times 2. The base stays the same because this is 3 2's. This is 4 2's, and this is 1 2. So this is 2 to the 8th. We don't multiply the 2's themselves and get 8 to the 8th. Okay, so because the base is staying the same. We have 8 2's. We don't have 8 8's. Okay, does that make sense? Hopefully it does. You can't really answer me. So anyway, let's continue to the next one. All right, here we have another product of powers question. If you'd like to pause the video and try this one by yourself, you can restart it when you're ready and check your work. If not, you can stay with me and we'll jump right into this problem. I have x cubed times x to the negative 2nd times x to the 5th. Now, I'm not going to write all my factors out on this one. I'm going to use that nice little shortcut. My shortcut says keep the same base and add the exponent. So my exponents are 3, negative 2. Notice I'm writing out plus negative 2. Plus 5. And then I simply evaluate that part of the expression. 3 plus negative 2 is 1, and 1 plus 5 is 6. So when I simplify that, I should get x to the 6th. Straightforward, right? Okay, our next rule is the quotient of powers. And quotient is simply dividing, and then powers, again, is our numbers that have a base and an exponent. So we have 8 to the 4th over 8 squared. And unfortunately, even though you're used to this symbol from elementary school, maybe even in middle school, this division sign, we don't tend to use it much once you get into your higher levels of math. So we see that fraction bar, that's a division sign. It's saying the numerator divided by the denominator. Okay? So we're going to write this in expanded form, but just like with the product of powers, our whole justification, our purpose behind doing this is to come up with a shortcut. Okay, so I'm going to write out 8 to the 4th. Oops, I'm not literally going to write 8 to the 4th. 8 times 8 times 8 times 8. And in my denominator, I've got 8 squared, so that's 2 factors of 8. Now think about what you know. Okay, this is the numerator divided by the denominator. Okay, so when we look at this, just like when you learn to reduce fractions, we look for a common factor. Well, here's a common factor right here. There's 8 divided by 8. Any number divided by itself is equal to 1. So those essentially cancel out, leaving only a 1 behind. Well, you have another factor that cancels out. You have 8 divided by 8 again, leaves behind a 1. Now all that's left in the numerator is 8 times 8. There's nothing left in the denominator, so I'm not even going to write that back out. So if I write that out as powers, well, 1 times 1 when you're multiplying, you really don't need to write it again because anything times 1 is itself. That's that multiplicative identity property. So what is left is a base of 8 used twice. So 8 times 8 gives me 8 squared, not 64, but we're actually just writing them as exponents or as exponential form right now. So the shortcut here, I want you to look at what we did. I started with 4 up here, and I divided by 2 down here. Okay, well, what I really did was I took away these 2 factors because they canceled out. They divided out as a common factor and went away. They disappeared because they divided to make 1. So the shortcut here, when I'm dividing numbers that have the same base, is that I can actually subtract the exponents. And that should make sense because when we multiplied, we added the exponents. The opposite of multiplication is division, so it makes sense that we should subtract the exponents when we divide. I want you to note that even though I used 4 and 2, 4 divided by 2 is 2, that's coincidence. Okay, we are going to be subtracting the exponents because we're taking away these factors. All right, let's continue. Just like before, if you'd like to pause the video and work this out on your own, just pause and then hit play again when you're ready to start. So here I have another quotient of powers problem, and what was our rule before? We were going to subtract the exponents. So just like I did on example 2, I'm going to write this with my base staying the same, my y, and then I'm going to write my exponents out. Now this is a really common type of problem that throws students off. Okay, a lot of people turn around and they write this. Then they can't figure out why they get it wrong. What do you notice is missing? Hopefully you notice that this exponent here is actually negative 3. So I'm going to be doing 7 minus negative 3. Okay, well what we know about our integer rules is when we do a minus a negative, that actually converts into adding a positive. It's like taking away a debt. Okay, so y to the 7 plus 3 is going to give me y to the 10th. Now, when we come back to negative exponents, we can look at another reason for this. Okay, but I just want you to notice that what ends up happening is because when you get to negative exponents, that y to the negative third is actually the reciprocal of y to the third. So we have to take this y to the negative third and flip it over. So what we end up doing is moving this up here, and it becomes 7 plus 3, which is 10. All right? All right, let's do one more with quotient. Now, I bet I know that some of you looked at that problem and went, oh my gosh, I can't do that. That's huge. It's a fraction. No way. This is still just a quotient of powers problem. So if you'd like to pause, work it out on your own, and then hit play when you're ready to go, go ahead and do that now. The rest of us are going to keep on working. So the thing with the rules of exponents is that they only apply to one base at a time. Okay, so what I'm going to do is look at this in its component parts. Okay, this is numbers or coefficients, a's, and then b's. And so what you could really do is look at this as if it was 24 over 12 times a to the 7th over a to the 3rd times b over b to the negative 3rd. And that should look more like the last two problems that we did. We're really dealing with each one on its own. Okay, so the thing to remember here, probably the biggest issue that people have, is remembering that this part is still a division problem. This is not 24 minus 12, it's 24 divided by 12. So 24 divided by 12 is 2 over 1, or just 2. And I like to go ahead and put the 1 until I get to the end, because it is possible that we could have one of our powers ending up in the denominator still. Or we could have a number that's not a 1 in the denominator. So I'm going to leave it as a fraction for now. All right, so now I have a to the 7th over a to the 3rd. Well, the rule was that we subtracted the exponent, so that's going to be a to the 7 minus 3, which is 4. And then my last one, remember the two things we talked about, the kind of little tricky things. One is that a b by itself is actually b to the first power. And then, since this is a quotient of powers problem, I'm subtracting exponents. So this is going to be b to the 1 minus negative 3. So hopefully that didn't trick you into saying negative 2. 1 minus negative 3 is 4. So that's going to be b to the fourth. Now I can put my numbers back together. I ended up with all ones in the denominator, so I'm not even going to write a denominator here. I'm just going to write this as a single term, 2, a to the fourth, b to the fourth. And there you go. That wasn't so bad. So it looks a little scary up front. Just break it down into its component parts and take each one on its own. All right, our next rule is a power to a power. And so this is exactly what it sounds like. We're going to be taking one power, so our x to the third here, and raising it to another power. We're going to be raising it to the power of 2, or to the second power. So the giveaway with these type of problems is that these are always going to have some parentheses involved. And so what you're going to see is some term. So you might see like this x cubed, you could see 2x cubed, you could see 2x cubed times y, you could see pretty much anything, but it's going to be in parentheses with another exponent on the outside, all right? So just like before, I want to break down why this works the way it does, and then I'll show you the shortcut. So think about, again, what the base and exponent have been telling us all along. This is telling us that we're going to use the base, x cubed, as a factor. How many times? We're going to use it 2 times. So this is really x cubed times x cubed. Well, if I broke this down just like I did at the very beginning, this is x times x times x times x times x times x, which is 1, 2, 3, 4, 5, 6 x's, so x to the 6th. Now the shortcut is, if you look at what this is saying to do, multiplication is when we have a certain number of equal groups. So if we look at the exponents here, this is saying use 2 groups of 3 factors of x each. So if I have 2 groups of 3 each, 2 times 3 is 6. So the rule here is simply to multiply the exponents. Now this is not multiplying the exponents in the sense of using the power. So some people make the mistake of doing like 3 to the second power, and that's not what we're doing. We're going to multiply them straight ahead. So 3 times 2 gives us 6. All right, so here's our next problem with power to a power. Now I know, again, a lot of people probably look at this and go, oh, that's too much, that's different. It's still the same rule. Now I want you to think about one thing that we've been talking about, which is that all numbers have an exponent, and if there's not one written, it has an exponent of 1. Now I want to point out one thing here that can be a little bit confusing. Sometimes people look at a number and then like they group the numbers together until they hit an exponent. So what I mean is some people would read this as being 2x to the third power, which essentially they would look at as being 2 to the third, x to the third. But that 3 belongs only to the x. Okay, numbers are greedy with their exponents. Okay, so when you see this, this is actually, I've got it up here to the side, that is 2 times x times x times x. And if we bring the y in, times y. So only the x is raised to the third power. So 2 has an exponent of 1. The y has an exponent of 1, and that is super important to remember. One thing I tell my students to do all the time when they're dealing with power of a power is to make sure you go ahead and put a 1 on any number that does not already have an exponent. Okay, now the shortcut to this is you're essentially going to distribute. Okay, so I'll write it out in expanded form, but you don't have to do that. This is really saying use 2x cubed 3 times. So if you look at what I've got 1, 2, 3 factors of 2, 3, 6, 9 factors of x, and 1, 2, 3 factors of y. Now the shortcut to that is, as I was just saying, is essentially just to distribute. So if you remember when you did distributive property, that was when you multiplied a number times multiple terms within parentheses. So it's not really distributing, but it's pretty similar. So I like to draw the little arrows and take a shortcut. So that's 2 to the 1 times 3 is 3. X to the 3 times 3 is 9. Y to the 1 times 3 is 3. And hopefully you can see after writing out the factors how that shortcut really works. All right, here's one of my favorite things about exponents is dealing with something raised to the 0 power. We are so used to anything involving 0 equaling 0 because, anything times 0 is 0. Adding 0 doesn't change a number. Okay, but exponents of 0 are a weird thing. Here's the rule. Anything to the 0 power except for 0, and it's a special case, anything else to the 0 power actually equals 1. And I always have people who are like, why in the world does it equal 1? Well, now that we've talked about the quotient rule of powers, it'll make perfect sense. If I take, let's say, 9 squared over 9 squared, the quotient rule of powers says I subtract those exponents, so 2 minus 2, and that equals 9 to the 0. But if I didn't know this rule that your teacher just said, that equals 1, I'd be like, why does that equal 1? I would think it equals 9 because there's a 9 and there's no exponent. Well, look at what's going on here. Any number divided by itself, what does that equal? Okay, that's, even if you evaluated it, that's 81 over 81. Well, any number divided by itself is equal to 1. So that's why anything to the 0 power is equal to 1. If you divide a number by itself, you're essentially subtracting the exponents, which leaves you with 0, but dividing the same number by itself is equal to 1. There's one other great way to look at it. If you're interested, if you're not, you can certainly fast forward a little while I erase this extra work. I'm one of those folks, I like to have good explanations for things instead of just saying, take my word for it. I want you to know why. If I was to take my powers, 9 squared, 9 to the first, and 9 to the 0 power. 9 squared is 9 times 9, which equals what? 81. 9 to the first is 9, which is 9. Okay, what am I doing as I go down by my exponents? Well, that's really 81 divided by 9, which is 9. And 9 divided by 9 is not 0. 9 divided by 9 is equal to 1. And if we continued that, we would actually jump right into negative exponents as well. So this is a really good way to look at it if that quotient rule doesn't go for you. If you're just happy with it and you're not really concerned with the y's, just memorize that anything to the 0 power except for 0 is equal to 1. All right, negative exponents are up next. And a negative exponent is a little bit weird. We look at that negative and what we kind of want to think is, let me just do the problem and then I'll make the answer negative. But that's actually not what's going to go on. What's going to happen here is we're going to be taking the reciprocal of our base. And if you'll remember, the reciprocal is simply when you take the inverse of a fraction or you flip it over. Okay, so with a negative exponent, all we've got to do is remember that there's actually a 1 in the denominator of every whole number, or any number. We're going to flip that over, and we're going to make the exponent positive. So essentially what this is doing is taking the reciprocal of this number to this exponent, ignoring the negative, okay? Now I'm going to show you on the next slide another reason for how to kind of understand that negative exponent. But for now, if you'll just remember to flip the fraction, and then switch the sign. Some students like to say keep flip change, but they use that for everything, so I wouldn't recommend memorizing that way. I tell them about a song that goes flip it and reverse it. That's what I remember. We flip the fraction, and then we reverse the sign. So here we go with a number that's got a negative exponent, a nice number base instead of just a variable for a base. We have 12 to the negative second power. If you remember what we did on the last problem, we took the reciprocal of this and we made the exponent positive. And then we can actually evaluate this one because we do have a number base or instead of having a variable for a base. So we can work out 12 squared is 144. Okay, now I like to show this example. If you're not overly interested in the why of the negative exponent, you can certainly fast forward. But if you want to understand why it works this way, stay tuned. So if I take 12, and let's do 12 to the second, to the positive second. That's 12 times 12, which is 144. I'm going to do 12 to the first, and that's just a 12. Now we just talked about how everything to the 0 power is 1. And I want you to notice that along the way here, I'm dividing by 12. every time. Now, if I was to continue my pattern, 0 decreasing by 1 is going to be negative 1. I'll go ahead and write out my 12 to the negative second. Well, if I keep this up, dividing by 12, 1 divided by 12, it's not negative 12. 1 divided by 12 is 1 divided by 12. It's 1/12. Okay, if I continue that, if I follow this pattern, I'm going to end up with 1 over 12 times 12, which is 1 over 144. Okay, because remember, dividing by 12 is the same as multiplying by 1/12. Okay, now I'd like you to notice what happened there. 12 squared and 12 to the negative second are really similar. You've got 144 and 1 over 144. So the numbers are reciprocals. The same thing happens with 12 to the first and 12 to the negative first. 12 to the first is 12. 12 to the negative first is 1 over 12. So that hopefully illustrates how numbers with negative exponents are simply reciprocals of their counterparts with positive exponents. All right, guys, you've done a great job sticking it out. This is the last problem before you get some practice on your own. So we have 1 over 4 to the negative second. Now I want you to notice what's different about this compared to the last two problems that we did. Well, hopefully you noticed that in this case, the power with the negative exponent is already in the denominator of the fraction. In the last two problems, it started out in the numerator and then moved into the denominator. We had 12 to the negative second became 1 over 144. Okay, but notice that this one, our power with the negative exponent, is already in the denominator. Now, I want you to notice that nowhere in my explanation of negative exponents did I say something about putting anything in the bottom. What was that R word I used? Reciprocal. Okay, so instead of just saying, oh, we always move it to the bottom, which is not what we do, we actually move things by taking the reciprocal. Okay, so since this one is already in the denominator of the fraction, where is it going to have to go? Well, if you said the numerator, you're absolutely correct. So what we're going to do is still flip this and then reverse its sign. So the reciprocal of 1 over 4 squared is 4 squared over 1. Okay, which becomes 16. Now, if you were to work this out as it is, what this is saying is 1 divided by 4 to the negative second. And what we just found out was that 4 to the negative second is 1 over 16, or 1 over 4 squared, which is 1 over 16. But if you remember what you've learned about dividing by fractions, dividing by a fraction is equal to multiplying by its reciprocal. And 1 times 16 over 1 is 16. Okay, so the big thing here, and the one thing I say, I try to use proper math terms as much as I can, but a negative exponent is really a sign that the number in question is in the wrong place in a fraction. So if it's a negative exponent in the numerator of a fraction, it's going to have to go into the denominator. And if it's a negative exponent in the denominator, like this problem is, it's going to end up going into the numerator. And that's a really easy way to remember it. I've actually seen people say it needs to go upstairs or downstairs. I won't go that far, but kind of keep in mind that that negative is kind of a red flag, that something's not right and it needs to move. The last thing to point out, and then we'll be done, is that when you make that move, once you've taken the reciprocal, is that the exponent becomes positive. That's the sign that you have fixed the problem. So once you've done it, don't leave a negative exponent in there, because that's a sign that it still needs to be flipped. All right, if you'll continue on, there's some practice problems for you to do, and then some answers. All right, guys, you've made it to the practice. So what you can do is pause the video to work these problems out, and then when you're ready to go, hit play again, and I will show you the answers. All right, so hopefully you guys did well. Just a real quick explanation. If you got them all right, you can stop the video now. If you need an explanation for any of them, just stick around. So this first problem, notice that I've got 3 bases going on. I've got a 2, then I've got some x's, and then I've got some y's. And so just like we did with the fraction in the lesson, you're going to deal with each base on its own. Well, the 2 cannot be combined with anything else, so it's just going to be a 2. If I had another 2 in there or another number, I could multiply them together, but for this, just going to leave a 2. Now I've got my powers of x. I've got x to the 3rd times x to the 5th, and we know to add those exponents, so that's going to be 3 plus 5 to give me an exponent of 8. And then hopefully you remember that this y that's all by himself is actually y to the first power. So when I combine that, that's going to be y to the 1 plus 4 is 5. Continuing on to my fraction problem. I threw a little bit of a twist at you with the 25 over 10. 25 over 10 does not divide out evenly, so we actually are just going to simplify that as a fraction. 25 over 10 does have a common factor of 5. So when I divide both of those by 5, the numerator and denominator, it leaves me with 5 over 2. Now I'm going to look at my a's and my b's. Hopefully you dealt with those separately just like we did in the previous one. A to the 5 minus 3 is going to give me a squared. And b to the 4 minus 2 is also going to give me b squared. And that 2 must stay in the denominator because we had to divide by 2. Every once in a while someone will go ahead and divide out the 25 over 10 or the 5 over 2 to get 2.5. That's not wrong, but just more often than not, you're going to see that still written as a fraction, so don't let that confuse you if you're depending on the decimal there. Moving on to the next one, 4 to the negative third. Hopefully you had no problems with that one. When we do that, 4 to the negative third, we take the reciprocal, we flip it, and make the exponent positive. We reverse it, and then we simply work out 4 to the third. I always have students go, where are you getting 64? Well, 4 to the third, that's 4 times 4 times 4. 4 times 4 is 16. Times 4 is 64. And for my last problem, I have 5y squared z raised to the third power. So remember that each number within that product has its own exponent. This is not 5y squared, so 5 squared y squared. That's actually 5 times y times z. So when we work this out, go ahead and put yourself a 1 on the 5 and on the z. Then I'm going to distribute. It's going to come 5 to the third, y to the 2 times 3 is y to the 6th, and then z to the 1 times 3 is z to the third. Now you'll notice that I went ahead and expanded that and worked out what 5 to the third equals. It is possible, like if you're doing a test where you have multiple choice where it's already generated for you, that you might see the standard form. So you won't always see 5 to the third. They might go ahead and work out 5 times 5 times 5. So 5 times 5 times 5 gives me 125. 5 times 5 is 25. Times 5 is 125. And that's it. Hopefully this lesson was helpful to you. If you still have questions, make sure to talk to your math teacher and they will be happy to help you out. Until next time, happy problem solving.